So today's lesson is going to build off of what we've done previously. So we talked about calculating the equation of a least squares regression line using our applet, and then also using some summary statistics. What does that tell us? And describe how outliers affect that least squares regression line. So again, in our lab packet for today, you're going to notice that you have two papers for 2.6 to do your sketches for your scatter plots with the regression lines, correlation coefficients, and the equations. We're going to add to those accordingly. So we have the visuals to go with our write-up sheet that we normally do in class for our 2.6. And this is our write-up sheet here. So we're going to use kind of all three of those together. So if you want to take those out of your packet and line them up, you can, or just make sure you're flipping back and forth. The first drawing kind of lab sheet goes with this first set of data here. And then the second one will go with when we add in this additional score. So as we're looking at our first question, it says use your applet to make your scatter plot and click your least squares regression line. So remember to do this, you're going to your applet and we want to pick the two quantitative variables and enter your items in. We can do GPA as the response and GPA as your explanatory and ACT as your response. Once we have it all entered, we can click Begin Analysis. It will give us our scatter plot. And remember, below the scatter plot, it'll also give you the correlation coefficient. You want to click on that. So we'll pause the video here, give you time to enter that data, and then we'll check before we proceed. All right, so by entering it in, like we said, the explanatory and the response, we're getting a scatter plot looking like this. And when I asked it to calculate the correlation coefficient, we got 0.955. So it's strong, it's positive. I'm going with the form being linear because I'm looking at how the points are arranged. It is not determined by the value for R. Remember, we're looking at the direction of the points, how are they arranged, and I can see if it's a linear format or a nonlinear format. And I kind of see this linear piece happening here. When we look at some of the summary statistics that come when we click on create the regression line, like we did yesterday, here it comes up, right? So we have the equation, right? The predicted response variable comes from negative 15.1 plus 11.5 times the explanatory variable. This tells us how many pieces of data we had in our set. S, remember, that's the standard deviation of the residuals. And then R squared, that's your coefficient of determination. Remember, this is telling you that it's improving your predictions for your Y's, your Y hats, your response variables by 91.2%. Again, if you look at the residuals itself, remember this is where the 0, the actual, and the predicted are exactly the same. We like to see that they're not too far away. So remember, this is just arranged vertically and you're kind of measuring the distance you are from that actual line. This, the actual here, is at 0. You're doing the distance just horizontally. So let's go back and add this equation into our write-up for 2.6. And remember in words that the predicted ACT score comes from negative 15.1 plus 11.5 times the GPA. And this is what it looks like with your variables. Now we want to explain what the parts of the equation means again. So it says, what's the y-intercept of the equation of the regression line and what does it mean? Well, the y-intercept is going to come from that value of negative 15.1. And so what does it mean? It's saying that the predicted ACT score for a student with a GPA of 0 would be negative 15.1, right? But it doesn't make sense to have a GPA of 0. Doesn't make sense either to have a score for the ACT being negative 15.1 since ACT is what, 0 through 36. I don't even know if they have 0. We'll have to double check with their scoring. But again, it doesn't make sense, and that's okay. This is a line of fit. So this is what the equation is telling us, but in reality, we know it doesn't make sense. Again, that's going back to that idea of extrapolation. And we're talking about the slope of the equation. Remember, that's the part with your explanatory variable. So we're talking about the 11.5. And so what does it mean? For every 1 point increase in GPA, we predict that the ACT score will increase by 11.5 points. So that's the meaning of what we're working on. Every 1 point increase for this gives us this. So that's from the original data set. Now, if you look at this new part, we're adding one more student who has a GPA of 3.0 and an ACT score of 28. So we're going to go back to our two quantitative variables, and we're just at the end, we're going to add the 3.0 and we're going to add the 28 for the ACT score. Hit begin analysis again, and we're going to see what happens to the scatter plot, the correlation coefficient, and the equation. So we'll pause here and let you enter those changes and do the sketches on your second lab sheet. So again, here's our addition of 3 for the GPA and the ACT for 28, and this is what our plot looks like, a little bit different than before. When we do the correlation calculation, it's now 0.71, so it's still strong, not as strong as before. It's positive, and we still see the linear pattern being formed here on our graph. Now, when I go to get the equation for regression, again, here we can see that linear pattern, right, for our equation. Here's our equation. We have 7 sets of data now. This is what happened to our standard deviation of the residuals, and this is what happened to our coefficient of determination. Again, there's a change from before, where the standard deviation of the residuals was like a 1.7, so this definitely increased. And then our coefficient of determination decreased. It was a 0.9 before, now it's at a 0.5. So this is only improving our predictions by 50.4%. So let's do our interpretation, right? So we have our equation here, and let's kind of go through that. You also can see, I should mention, right, the residual. Here's where the 0, the actual, and the predicted are the same. We can see the distances from them and how that changed from our ones from before. All right, so we're going to write this in words and then we'll put the equation in, right? So our predicted ACT score is going to come from negative 3.354 plus 8.354 times your GPA. Again, here it is with our variables, right? Our predicted output comes from this plus this times our input. All right, if we talk about the interpretations for the new equation, talking about the y-intercept, so that's coming from the negative 3.354. So it's saying if you have a GPA of 0, your predicted ACT score is negative 3.354. Again, we're in the same place as we were before. It doesn't make sense in context, so that's going to the idea of extrapolation. Our y-intercept did increase, right? It was at a negative 15 before, but now it's at a negative 3. So this outlier pulled the line towards itself. So it increased it and made that change. Now, in terms of the slope, that was our multiplier, right? There was a change there as well, the 8.354, so that was a decrease. So again, for every 1 point increase in your GPA, you predict that the ACT score will increase by 8.354 points. So again, that slope decreased, the line is less steep. And we also pulled the line up from where that y-intercept originally was at negative 15.1, so now it's negative 3.354. So what are the main ideas from today, right? So we've been talking about the least squares means the smallest number of squares or residuals. So we want to minimize the sum of the squares. So we're talking about the distance away from the actuals and predicted, right, that make up our line of fit. We always use the applet to find our equations. So we can see, like here in red, we've got these as our original data values, and this was the line of fit based on the residuals, doing all those actuals minus predicteds to come up with that line. Depending on when you add in these values, these outliers, we can see the ones here in green. If I added something like that, it's going to pull the line up towards that, right? It's going to have a raise in your y-intercept. If I had something like here in purple, we can see how far away from the data set is. It's going to lower our line and fit, right? So it may raise the y-intercept, but lower your slope, and we can see that effect here. So the outliers that we talked about by adding in that extra data point could pull that line towards the outlier itself. So it might have an increase in the slope, but we're going to maybe increase or lower the y-intercept, but that line's going to get closer to that outlier like we see here in green, or it's going to lower that slope to bring it down towards that outlier that we see there in purple. So again, it's going back to changes in your slope and your y-intercepts. And remember, any extreme values for your x's, your explanatory variables tend to be paired with less extreme values for your y's, your response variables. So today's lesson built off the previous one. We were just looking at more of the ways that the outliers are impacted, how it changes your equations, as well as your coefficient of determinations and your correlation coefficients. You're going to practice all those ideas today on your application for 2.6. We have a set of roller coaster data, so do taller roller coasters go faster? So you have a variety of heights and maximum speeds. You're going to use your applet to make your scatter plot and do an accurate sketch. So we want scales labeled with words and numbers. Based on that, you're going to talk about calculating the least squares regression line using your applet, and then sketch that on the graph we used above, and also write the equation here. If you want to write it in words and symbolically, that would be fantastic. And then we're going to look to see if we add one more roller coaster, how would that impact your data, write the new equation, and talk about how it impacted that equation. All right, with that in mind, we'll see you at our next lesson.